Good day, so you're now on the 7th example, a multi-period scheduling example. So the problem here is, PM Computers assembles its own brand of personal computers from component parts it purchases overseas and domestically. PM sells most of its computers locally to different departments at State University, as well as to individuals and businesses in the immediate geographic region. PM has enough regular production capacity to produce 160 computers per week. It can produce an additional 50 computers with overtime. The cost of assembling, inspecting, and packaging a computer during regular time is $190. Overtime production of a computer costs $260. Furthermore, it costs $10 per computer per week to hold a computer in inventory for future delivery. PM wants to meet all customer orders with no shortages to provide quality service. PM's order schedule for the next week is as follows. For the first week, they have an order of 105. For the second week, an order of 170 computer. For third week, the 230 computer. For fourth week, 180. For fifth week, 150. And for sixth week, they have an order of 250 computer. So for the decision variables, this model consists of three different sets of decision variables for computers produced during regular time each week. This will result in 6 decision variables for regular and overtime production and 5 decision variable for inventory, because the problem stipulates that there is to be no inventory left over at the end of the 6-week period. And as a result, there is a total of 17 decision variables. So the variables here is R sub j, which is regular production of computer per week, O sub j, overtime production of computer per week, and I sub j is equals to extra computer carried over as inventory in week. The objective function. So the objective function here is to minimize the total production cost, which is the sum of regular and overtime production costs and inventory costs. So $190 times the regular production of computer per week plus 260 times the overtime production per week plus 10 times the inventory carried per week. So for the model constraints, available regular production capacity of 160 computers per week is R sub j is less than or equal to 160 computers in a week. Available overtime production capacity of 50 computers per week. O sub j is less than or equal to 50 computers in a week. Regular and overtime production and inventory necessary to meet the order requirement each week. Where for week 1, R sub 1 plus O sub 1 minus I sub 1 is equals to 105. For week 2, R sub 1 plus O sub 2. No. For week 2, again, R sub 2 plus O sub 2 plus I sub 1 minus I sub 2 is equals to 170. For week 3, R sub 3 plus O sub 3 plus I sub 2 minus I sub 3 is equals to 230. For week 4, R sub 4 plus O sub 4 plus I sub 3 minus I sub 4 is equals to 180. And for week 5, R sub 5 plus O sub 5 plus I sub 4 minus I sub 5 is equals to 150. For the 6th week, R sub 6 plus O sub 6 plus I sub 5 is equals to 250. For example, 105 computers have been ordered in week 1. R sub j and O sub j will meet this order, whereas any extra production that might be needed in a future week to meet an order, I sub j is subtracted because it does not go to meet the order. Subsequently, in week 2, the order of 170 computers is met by R, regular production and overtime production, plus inventory carried over from week 1. So for the model summary, the complete linear programming model is summarized as minimize Z is equals to $190 times the regular production per week plus 260 times the sum of the overtime production per week plus 10 times the inventory produced per week, subject to R sub j is less than or equal to 160, O sub j is less than or equal to 50, R sub 1 plus O sub 1 minus I sub 1 is equals to 105, R sub 2 plus O sub 2 plus I sub 1 minus I sub 2 is equals to 170, R sub 3 plus O sub 3 plus I sub 2 minus I sub 3 is equals to 230, R sub 4 plus O sub 4 plus I sub 3 plus I sub 4 is equals to 180, R sub 5 plus O sub 5 plus I sub 4 minus I sub 5 is equals to 150, R sub 6 plus O sub 6 plus I sub 5 is equals to 250. R sub j, O sub j, I sub j is greater than or equal to 0. So for the computer solution with Excel, the formula for objective function in cell C14, so this one, the total cost, is the sum product of the cell B6 up to B11 and the D6 to D11. So this is the formula, the sum product. If you don't want to type or for other choice, you can either type equals sum product, open and close parenthesis, B6 colon BI, comma, D6 colon D11, close parenthesis, then enter. So this is the result. The decision variables for R sub j are included in cell B6. So B6 to B11. So these are the decision variables. For overtime production are in cell D6 to D11. The computers available each week in column G, the available computers, includes the regular production per week, plus overtime production per week, plus the inventory. For example, in cell G7, computers available in week 2 has the formula of B7 plus D7 plus I6, which is the inventory from previous week. To get the inventory, you need to subtract the computers available to computers order. Okay? So, solution analysis. PM computers must operate with regular production at full capacity during the entire week period. It must also resort to overtime production in weeks 3, 4, 5, and 6 in order to meet heavier order volume in weeks 3 through 6. So next is sensitivity analysis. As each week passes, PM computers can use this model to update its production schedule if order sizes change. For example, if PM is in week 2 and the orders for week 5 changes from 150 computers to 200, the model can be altered and a new schedule computed. The model can also be extended further out into the planning horizon to develop future production schedules. PM may want to consider expanding its regular production capacity because of the heavy overtime requirements in week 3 through 6. The dual values for the constraints representing regular production in weeks 3 through 6 show that for each capacity increase for regular production time that will enable the production of one more computer, costs can be reduced by between $70 and $80. This total reduction would occur in processing time could be reduced without acquiring additional labor, etc. If additional resources were acquired to achieve an increase in capacity, the cost would have to be subtracted from the shadow price. That's all. Thank you for listening.